So that's going to be our rules. A class is a collection of data, variables, and methods that act upon that data. Rules 1 and 2. Data private, methods public. And you can have private methods as well, but you wouldn't be able to call those methods from the client code. You could only call it from within the class. And maybe there's times you want to do that, but usually not. Usually you want, the methods to be accessible to some client code. Client code being either the code that's, in the main method, in the main Java, or, one class can be the client of another. And so the act of doing this, data private and methods public, is called encapsulation. So what we're going to do is create a simple, itchy-bitchy little program where we're going to have 2 or 3 classes. We're going to have a class called car. And the class is going to have 4 members. Wheel 1, which is going to be a wheel. Wheel 2, which is going to be a wheel. Whee. Thought that looked odd. Wheel 3, which is a wheel. And wheel 4, which is a wheel. And it's also going to have miles, so that we can keep track of how many miles it's been driven. So then we're going to make a method called drive, not dive, drive, where we pass in the number of miles driven as an int, and it doesn't need to return anything. So all these things that say minus, they weren't meant to be just bullet points. It was actually supposed to be that, oh come on. I don't ever know how to convince a word to stop doing that.
You have to lobotomize it.
Yeah,
This word always knows best.
that's why I have notepad
Yeah.
for note taking.
Alrighty. The minus sign means that these variables are all going to be declared private. And the plus means that these functions are all going to be declared as public. Now besides the drive method, we're going to give what's known as a toString method that'll print out or return state information about the car, how many miles it's driven. Really, that's the only thing we're keeping track of besides the wheels. So that's going to return a string. And then we want one more, which is a constructor that makes the car. And it doesn't return anything because it's a constructor, so I'm just going to put a hint here that it's a constructor. Now what I would like to do would be to create a table that looked all nice and pretty, and I'm not sure I'm going to be able to do that. It almost worked. Okay. Now, then. Can I highlight those two things and say that I want a top and a bottom to them only? I may give up on this pretty quickly. Sometimes I can do this really fast, sometimes not. There we go, outside borders. Okay, that worked. Except I did not want that there. I wanted all three of these guys. Okay, this is going to be the thing with the outside borders. Let's try that again.
That's the only one.
Okay, so, yeah, this needs to be part of it as well. So, let's insert a column up here. Sorry to be picky.
That's fine.
Rows above. What? It's a rather large row. There we go. And it's looking really stupid. I'm not going to mess with it anymore. The top block is supposed to be the name of the class. This is what's known as a UML diagram. Universal Modeling Language. It's for describing classes. Where did that line come from? Anyways, and then the middle box is supposed to be the data. And then the last box are the methods. And later on you'll see these things get called different things. Some languages like to call these fields rather than variables. Some languages like to call these behaviors. I don't recall what this text does. But these are the methods. All of these are the methods. Can I just delete that one? Alright, that's better. Okay, so this is implying that we have another data type here, something called wheel. So we're going to make another class that has a wheel, or that's called wheel. Wheel, and all it's got in it is a miles driven. That's the only thing that we have on there. And then it's only going to have two methods. One is a drive or spin. Let's go with drive because that'll be the same thing that this is called. Which again takes the number of miles that it has been rolled, spun. I'm kind of liking the idea of spin. Okay. And it doesn't need to return anything, so we're going to declare that one as void. And it's going to have a constructor as well. Constructor's also public. It doesn't have a return type because no constructor has a return type. The definition of a constructor is a method that has the same name as the class with no return type. It is called or invoked by the new keyword when the object is being created. Okay, I think that's about enough. 3 lines here. Some point in the future I'll make it prettier, but you get the idea. That's our, oh really? Why did I have to go over there? First box again is our class title. The next one is all the data that's in the class. And the third one are the methods that act upon that data. So let's pop open NetBeans and actually create our little project. I'm going to call this car. No, I'm not. Call it car project. Don't call it anything on that screen. I always do that. I start typing stuff there. Pick that it's a Java application and call it car project. The reason I'm not calling it car is because car is one of our data classes. And you don't want your main method to be inside one of your data classes. So I don't want a main method in wheel. I don't want a main method in car. Instead, I want some client code that's going to use these classes. So that's why I did not call it car. I gave it a neutral different name, and the main method in there is going to use these classes. When NetBeans pops up, there's my car method, my car project class. But we want to add two more classes to it, the ones that are specified in that Word doc I've made with the UML diagrams. So come up here to the package where it says car project. That package matches that name. Do that under projects. Projects, right click on car project and do new Java class. I'm going to call one of them car. And then do the same thing and add another one called wheel. Right click on the package name again, choose Java class car, and then another one called Java class. Make it called wheel. So the client code is this original one, the car project.java, or whatever it was that has your main method in it, right there. This will use our car. Somewhere it's going to have a statement like this. Car C1 is equal to new car, and that will call the constructor. Now right now we don't have a constructor in the car class. Java gives you a default constructor. The default constructor, all it does is accept nothing between the parentheses, and that's it. Doesn't do anything. But we can go and put our own constructor in, which we will. So what do we need to add to our car class? We need the constructor, the drive, the Twostring methods, and our 4 wheels, and a mileage indicator. Let's take care of our data first. Wheel, I'm just going to call it W1, is equal to, yeah, that's enough. Wheel W2, wheel W3, and wheel W4. We have 4 wheels on our car. For these to actually be created, don't type this, I'm going to have to do something like this. Somewhere at some point, in order for these wheel objects to be made, there's going to have to be a new keyword. But we're not going to put them there. Instead, we're going to put those in the constructor. So we'll get to that. And we need a miles indicator, int miles. And let's put private in front of all this stuff. Alright, we've created our data. We're going to add some methods. I'm going to leave the Twostring method for last, but I do want to do the drive method, and I do want to do the car method. So now we're going to add the constructor. A constructor is a class that has the same name, it's a method that has the same name as a class with no return type. You declare them as public because it would be pretty odd to try to have something created. Anyways, has to be public or else the client code can't construct it. Public car, we're not going to accept any parameters. When does a constructor take parameters? Well, if it's doing something like scanner SC is equal to new scanner, and then there's things between the parentheses, system.in, that's data being passed into the constructor, but we're not going to pass any data in. Now when the object is being created, we want these wheels to be created. So this .w1 is equal to new wheel. This .w2 is equal to new wheel. This .w3 is equal to new wheel. This .w4 is equal to new wheel. And that's enough. We could also set miles equal to 0, but we really don't need to because these things default to being 0, which is great if it's a numeric type. If it's a reference type like this, you don't want to use anything that's set to 0. You'll get a null reference error. That's why we're doing this. We're giving ourselves some objects to play with. Until we do that, we don't actually have any wheels. We just have some references to wheels. It's like we put up some signs pointing to houses in the neighborhood, but we never built the houses. This builds the houses. Alright, now let's add our drive method. Oh, let's put a print message here just so we can kind of watch what's going on. System.out.println car created. Now we're going to add our drive method. Public void drive. It was supposed to accept a variable that said how many miles we've driven. And what it's going to do is it's going to spin each wheel that many times. Now this is going to give us an error when we type it because we haven't implemented the wheel class yet. But that's okay. Go that many wheels. Many miles. I'm going to copy and paste that line because I wanted to do W2, W3, and W4 the same way. And then a print message. System.out.println car drove plus miles, something like that. Now it makes me nervous that we have those errors there, so we're going to go correct them. But I don't want to tab away from this before people have had a chance to type it in.
You have 3 W2s and
Yeah, I do. I created 3 tires and I put them all in the same spot.
That's a very interesting car.
Yeah. Okay. All right. Let's see if I can get this going so that we have 2 things being edited at the same time. Okay, so in the wheel class, I need my variables. There was another one called miles. And we had a constructor. This constructor is useless though. All it's going to do is print a message, so we really don't even have to have it. But we're going to put it there anyways. Public wheel has to match the name exactly. And I'm going to put this all on one line just to save some. If I could get these side by side, that'd be so awesome, and I don't know how to do that. Ah, what do you know? Okay. Now that I have them side by side, I'm not so afraid of doing that. Okay, there we go. And the last one, spin, which will make the car spin its wheel, or make the wheel spin. So public void spin, it has to spin a certain number of miles. So it increases miles by the number of miles that the wheel spun. This dot miles plus equal miles. And let's print a message, system.out.println wheel spun. I want to change this from printing out the miles that was passed in to the miles that's stored in the object. I want that one, so I'm going to make this say wheel spins this dot miles. And I'm going to change the message from wheel spin to wheel has spun. Alright, hopefully that fixes these errors over here. It did. The only thing I forgot to do is we have a mileage indicator on this class and we're not increasing it. So let's do that. This dot miles plus equals the mileage indicator that's being passed in, the variable that's being passed in. So this is the car class, this is the wheel class. I think what I'd like to do is add one more print message that says car driven, and then print out how many miles we've actually driven. Or let's make it say odometer. Odometer colon. And we'll print out this dot miles. Alrighty. So what's to note about this? One thing is, I think I've used this keyword before, but I'm hoping that this will, no pun intended, distinguish or show why we use it. Here, when I'm trying to print out the miles it's driven, and I just say car has driven miles, it kind of looks at it, tries to figure out what variable I mean, and decides that I mean the parameter that's being passed in. So if I want to do something with this one, I have to preface it with the word this. That's why it's a different color. These green things here are all members of this class. Usually you can leave this keyword off and it'll figure things out. But this line here would not work if this keyword was left off, because it would just say miles is equal to plus equals miles. It would think that it was modified. Both of them would be accessing that one, because the order in which it resolves variables are there any local variables? Are there any parameters? And then it goes, okay, now I'm going to look for class variables. But if you specify where it is with this keyword, it'll jump right up there and go, okay, that's the one that you mean. So we're going to go back to our client code, which is in the main method. And we're going to build us a car. We already have. Let's drive it a few times. So go back to your car project.java and do c1.drive. Let's drive a mile. c1.drive. Let's drive 10 miles. c1.drive. Let's drive 100 miles. It's possible this will actually even work. I wonder what it's going to do. Okay, so when I ran it, here's what it said. Wheel created, wheel created, wheel created, wheel created. we see the wheel constructor being called 4 different times because we created 4 different wheels with the new keyword. Then it says car created. That's done at the end of the constructor for the car. So all of that happened just when this one line was executed. When we see car C1 is equal to new car, what it did is it jumped in to find the constructor for the car because the new keyword was called. It ran all the code that was in the car class. Here's the constructor for the car, so it created a wheel. So it jumped into the wheel class. No. There. Jumped into the wheel class and called its constructor, which printed wheel created. Then it came back out and it did that for a second wheel, called that constructor. Did it again for a third wheel, called that constructor, printing that message out. One more time for the fourth wheel. Then it came out and it printed car created and it returned, and we were done with the constructor for the car object. So then we called drive. So when we called drive, it went over to the car class and it called this method, which spun the first wheel that many miles, 1 mile. Spun the second wheel that many miles. Spun the third wheel that many miles. Spun the fourth wheel that many miles. Then it printed out the car drove that many miles and the odometer's 1. Now we're back out here in the car project class. We're ready to call drive again. So that calls the drive method again. We're back in the drive method. It spins the wheel 10 more times. So it prints out, okay, we've spun 11 miles. Why didn't it print out 10? Because we told it to print out this dot miles, which is the class member, not the parameter that was passed in. So these are also like odometers, you know. Each one's keeping track of how far it is spun. And it does that for each wheel. It increases the mileage of our car by the amount of miles that was passed in. And then it prints how far the car drove and the current odometer. So after we have driven those 10 miles, our odometer is 11. Then we drove 100 miles. It spun each wheel again. Then it printed out how far it drove and then our current odometer. I don't know if that makes sense or not. I hope it does. I hope that we're seeing that you can put objects inside of objects. The client for the car class is the car project main method. He uses the car class. So he's the client for the car class. The car class is a client of the wheel class because it has wheels embedded in it. It uses wheel objects. When are the constructors called? When the objects are created with a new keyword. Do you have to put a constructor in them for it to work? No. If you're happy with the object being created and no messages being printed out and no changes being made to the data, it's totally cool not to put a constructor in. So you only put a constructor in when you think that it's going to do some good. And what I have left out here is I had one last thing on my to-do list, which was a Twostring method. A Twostring method is called when the object is being passed into something that expects a string, like a print statement. So we can make the car print out useful information about itself. I'm going to go back to the car class and add a Twostring method. No, I'm not. First I'm going to show you what it looks like if we don't add one, why we might want to. So after we've driven 111 miles, we're going to print out our car. System.out.println car. And it's going to print something that is underwhelming. Prints this out. This is the package that the class is in. That's the name of the class, and then this is some random hexadecimal number, probably the address of that specific object. We can make it print out much more useful information than that, though. So we're going to go back to the car class.
Okay, question.
Yes, sir.
My output window, I accidentally clicked and it is gone, and window output is not bringing it back. Do you have any idea what I did?
Oh, jeez.
I guess we're gonna have to format it. No, I'm kidding.
Window output does nothing.
That's wild.
It was fun.
Okay, what I did to bring it back is I just did window reset Windows and
Okay.
built it again. It seemed to have saved us.
Yeah, that one of those parent clicks. Thank you.
Sure thing. So we want to add a toString method so that when we try to print the object, it gives us more interesting information than just gobbledygook. So I'm going to go to the car class and do this, public string toString. And I have to decide what my string is going to say. I'm going to declare a string called R. And just set it equal to the word car. And then I'm going to add something to it. R plus equals has been driven plus this dot miles. R plus equals miles, and then return R. Initializer must be able to complete normally. Oh, I put a semicolon here. Newbie error. Okay, there we go. Now when I run it and it prints it out, instead of printing out that random message, it says car has been driven 1,100 miles. We could put anything in there that we wanted, but for diagnostic purposes, typically you want to make your toString method print out useful information about it. We could make the wheels toString method print out, how many miles that wheel has been driven or how much tread is left. If the car was tracking a lot of different information, like the number of gallons in the gas tank, or the the gas mileage or stuff like that, toString would need to print that out as well, so that we could debug the object, print it, and get some useful information about it.
No problem.
So, along with data private and methods public, we have more rules. Rule 3 is add getters and setters where appropriate, and the reason we need to do that is because our data is private. So if we wanted to access the number of miles that the car has been driven, right now our client code couldn't do that. So getters and setters, and then a fourth one would be add a constructor if it makes the class easier to use or more functional. And 5 would be add toString to help display data about the class. So I'm going to make some of these things kind of parenthetical. You don't have to add a constructor, but if it makes a class easier to use or more functional, go for it. In this case, we didn't really have to do it. I'll show you how I could have done it without it, but I liked doing it because I wanted it to print a message so that you would see in the order in which the things were being called. And then lastly, add toString to help display. So these are our 5 rules about classes. Rule 0 is name all your classes with an uppercase letter. Just every other thing we've done, we've always named it with lowercase letters, classes, uppercase. Okay, so what do I mean by getters and setters? Well, say my client over here, my car project file, say somebody asked us, how many miles have we driven, and we wanted to print that out. Now we're printing it everywhere else, we already know, but just say, okay. So say we wanted to do print C1 dot miles. We can't do that. But that variable is there. Why can't we access it? Because it's declared as private. So we need to add a getter. We're going to come over to car.java, and I think I'll just scroll up to the top above the constructor, although I like having the constructor as the top thing, but anyways, public int get miles return this dot miles. That's a getter. If I want to allow somebody to monkey with the odometer and change the number of miles, I would add a setter as well. Now, this is a getter. The technical name for a getter is accessor. I'm not going to add a setter because, in my opinion, the only thing that should change the miles that it has been driven is the miles method, the drive method. So now nobody can go in there and change the code in order to set the miles back to 0 after the thing has been driven 100,000 miles. No monkeying with the odometer. The only thing that ever changes the mileage indicator is the drive method. So this data has been encapsulated. It's protected from change. It has been validated because the only thing that changes it, the only time it changes is by something that we wrote. So we could hand this project off to somebody else. They could use our class, and we'd be pretty sure that if we came back to modify our code later, that we could still trust that value. As long as they haven't changed the class as well. If more than one person's monkeying with the class, all bets are off. So I'm not going to add a setter, but here's what it would look like. So I am going to type it, but then I'll comment it out. A setter doesn't need to return a value. Getter did. It had to return an int because that's what miles was. But a setter does not. So public void set miles, and I would need to allow us to specify the value. And this dot miles would equal miles that was passed in. So that's my setter, the mutator. But I'm going to comment that out because you don't have to add getters or setters unless you think that it's useful for a programmer who's using your class to be able to call it. There's a function inside of NetBeans, inside the refactor menu, which will go add getters and setters for every variable in your class. It would add getters and setters for each wheel. I don't really want them to access the wheel objects, so I'm not going to do that. Doesn't make sense. But add getters and setters judiciously for the data that the class has in it that a program might need to know. And in this case, if this thing wasn't so talkative, if it wasn't printing out how many miles it had driven and stuff like that, we would never know without the use of get miles. And realistically speaking, we shouldn't make a class that's so chatty. It should do all this silently, and then only the client code print messages. But I wanted all these messages to pop up, showing that when we call drive, it spun each wheel, that kind of thing. So for demonstrative purposes, I think that's okay. Now I could go back to my car project, and when I was trying to print out c1.miles, I would have to change it to c1.getMiles, but we would be able to print it. So getters get the data elements so that the client code can inspect them. Setters allow client code to change it. It can validate the values. Like even if we were going to allow the client code to set the mileage of the car, we might want to do some validation on it. We're not going to let them set it to a negative value. Only values of 0 or later or greater. So you can validate your data. That's part of encapsulation, is that if something is changing the data, then you, the programmer, can make sure that it's an intelligent change, and you can reject changes that are not valid. And that will keep the state of the object, its data, in a good state. Whereas if you had a car with a negative mileage on it, that's probably a mistake. So the class is the blueprint, and then the objects are built from the blueprint. Here we have one car made. Now let's make another one. Car C2 is equal to new car. We're going to drive this one 2 miles and then just be done with it. We're not going to do anything else with it, but let's print it out. Not get miles, just print the car out itself. So when I ran it, I saw the second car get its wheels spun, and then when we printed it out, it said the car has driven 2 miles. If we turn around and print car 1 again, it would say that the car has been driven 111 miles again. Now we have 2 discrete sets of information being managed. That's what makes classes cool, is you can have more, you're tracking information about more than one thing at the same time. Previously, we would have just been dealing with data that was one thing, one person's salary. Now we have, we could create as many cars as we liked. We could create an entire array of cars and then make them all drive, one after the other.
A whole fleet of cars.
Yes. The this reference, you use it in conjunction with a dot, and you give an instance variable or a method name after it. And what it means is that weight is a member of that class. If there was no class member named weight, then this would generate an error. Default values, everything inside a class, all of those class variables, and I should not have called them class variables. All of those member variables get initialized to 0. These are what are known as instance variables. Where's my car? These are instance variables. Each car has its own wheels. Each car has its own mileage. It doesn't make sense for multiple cars to share the same wheel. So these are all instance variables because they were not declared with the static keyword. It's too bad that there's no keyword that means it's an instance variable, but that's the way they designed it. You just have to use the static keyword, and if you avoid using the static keyword, then the default is that it's an instance variable. So why would you use a static variable? A static variable is data that's shared across all the classes, and you don't even have to have an object in order to access it. So let's make a static variable called num cars created or something like that, or just num built. I'm going to make it public to make it easier to access. So public int num built. And I don't know why, but I do feel like sticking equals 0 there. Now each time we create a new car, we're going to increase that. But we want this to apply for all the cars, because we don't want each car saying, oh, I've built 1 car. We want to be able to find out, total how many cars have been built. So we're going to do the word static, but I think it comes after the public keyword. There we go. Now our constructor down here, we want it to increase the number of cars that have been made. So num built plus plus. Now in this case I can't type this.numBuilt. all I can do is say num_built. And the reason why is you do not get to use the this keyword if you're talking about static members, class members. You only get to use the this keyword when you're dealing with instance members and instance variables. Because if you don't have a car created, I'm not going to even finish that explanation. So now, let's come over here to our car class again, car project. And we're going to write a line of code that prints out how many cars have been created. System.out.println cars made plus cars dot car dot num_built. Now it's not yelling at me about accessing that variable because it's a public variable. So it's okay to do that. Then I'm just going to copy that and I'm going to print it out here again at the end. Then I'm going to write a for loop that creates 1,000 cars for no good reason. For int I is equal to 0, or x is equal to 0, x is less than 1,000, x plus plus. Inside there we will do car C3 is equal to new car. That will create 1,000 new cars. We're going to see a whole bunch of messages go by on our screen because we made a chatty class. And then let's print out the number of cars made one more time. So just copy and paste that, and there we go. Tell you what, go back to the other classes and print and comment out the print statements. We don't really need them to be this chatty anymore. We understand what they're doing. So go to wheel and comment out the 2 print statements, and go to car and print out all the comment out the print statements. So the first print statement said cars made 0. If we go and look at the car project class again, how in the world was it able to access that variable? We haven't even built a car. Well, we didn't address it by the name of one of the instances. We addressed it by the name of the class itself. So that makes it a class variable. And the only reason that works is because num_built was declared as a static variable. It was declared with a static keyword, so that variable actually exists outside of the class itself. You don't even have to have any instances in order to be able to access it. Right now the constructor hasn't added anything onto the num_built, so that when we call this the first time, num_built is equal to 0. Now we went along and we created a new car. We came along here and we made another new car. And then when we called cars made again, num_built was equal to 2. Because each time we created a new car, the new keyword called the constructor, which incremented num_built. Then we had a loop over here in car project that created 1,000 cars. And even though after this point all those cars are gone, it'll still say that we've made 1,002 cars. Because it's a static variable, it doesn't matter whether all those objects have been deallocated or whatever. What do I mean by deallocated? Well, this creates a car, but then if I tried to access that car down here, c3.drive, something like that, I can't. Why is that an error? Remember scope. This car is declared here. This variable is declared here. It's only accessible between those 2 points. So when I try to get down here and print it, or do something with it, the reference no longer exists. And the object it was pointing to is now orphaned. Nothing is pointing towards it anymore. And when that happens, it's called an orphan object, and the built-in garbage collector, that's actually what they call it, comes and it cleans up the memory that it had occupied. Because an object could have a huge amount of memory. You know, what if it was an object representing a photo? You know, nowadays photos taken with 8 megapixel or 16 megapixel cameras are huge. So you would not want it to keep all that memory around just because you went from one photo to the next. You want it to completely, forget the old photo in order to display the new one. So as soon as this object is no longer referenced because the thing that pointed to it falls out of scope, then the garbage collector will come and it'll free up that memory. And that's a difference between this language and languages like C++, where you have to do lower level memory management. And programs written in C++ are very prone to getting what are known as memory leaks, which is that as the program runs longer and longer, it uses more and more memory. So when you come then, you click on Task Manager and you're looking at all your programs that are currently running, you could watch Firefox grow and grow and grow, and then you'd wonder why your PC was slowing down, and you came back a day later and it was occupying 10 gigabytes of RAM or whatever in your program, your PC crashed or whatever. It's because it had memory leaks. Like if you closed a page, it didn't actually release all the memory that had been stored to hold the elements of that page. So Java programs rarely exhibit memory leaks because of the garbage collector. So anyways, even though those objects have been destroyed, that static counter is still there. We could make all of this stuff go away. If we did this, if we went and we added an open brace up here right before the first card got created, and then a closed brace, I need to delete that C3.drive. Right there. By the time we get here, absolutely every object is gone. I can't get a hold of any of them anymore. I can't do C1.drive or anything because they are all out of scope. So how many cars is it going to say is built? Still going to be 1,002 because this num_built variable exists outside of the class itself. It's not inside any particular instance of the car. It's like there's a fill-in-the-blank field on the blueprint where you could write extra notes. So variable persistence. I've been calling this scope. A variable's persistence is how long the variable's value survives. Variable instances persist for the duration of the particular object. I don't even know what they're saying there. I'm going to kind of skip that. So a local variable is one that's declared inside a method. We have a local variable being used inside our Twostring method. If I go to car, there's a variable called string here. That's a local variable. It's created inside this method, and when this method is done running, that variable no longer exists. However, we are returning its value so that something else can use it. But this memory no longer exists. This variable no longer exists. It has local scope. It is a local variable. Up here higher, we have instance variables, and we have one class variable. The static variable is a class variable. The rest of these are instance variables. Instance variables can be accessed as long as that instance exists. That's the lifespan of that variable. When this car object is destroyed by the garbage collector or something like that, then the wheels no longer exist. And the garbage collector will come and clean those up too. This one, however, will never be destroyed until the program is done running because it exists outside of any class, any specific instance, because it's not an instance variable, it's a class variable. Local variables do not get a nice handy default value. And I'm not really sure that I've ever understood why. But if I do this, if I go into this code here, and I add a method, don't add this, void dummy, and then I do int, gas, something like that. This one gets initialized to 0, just like all of these got initialized to null. And truth be known, this one actually was initialized to 0 as well, and I didn't even need to put that value there. It just kind of makes me feel good to see these things get initialized, but you don't have to. This one, however, does not get initialized. It's got garbage value. And if I try to do something with it, like gas is equal to gas plus 10, it won't compile. The compiler picks up on that and says, variable may not have been initialized. So it's not a valid variable to use until I have assigned it a value. But that's not true of class member variables, either class variables or instance variables. These do get initialized to a hopefully useful 0. Goodbye. Local variables persist only for the duration of the method or the loop in which the variable is defined. So if I have a for loop in here for some reason, I could have written this drive method like this. For int I is equal to 1, I is less than or equal to the number of miles that was requested, I plus plus. And then I could have spun each wheel just 1 mile over and over and over. This I variable is no longer accessible. It is out of scope. By the time I get down here, I can't do that. I can't do anything about it. I can't get a hold of it down here, because it is local to this for loop, just as much as if we had defined something else in here. I couldn't get a hold of x either, because that x is inside these braces. We are underneath those braces. We can't get a hold of it. It has fallen out of scope by the time we get here. Why would we make it work like this? Well, maybe we want to make it say vroom, 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 vroom for each mile we go. I don't know. You stick it in a loop. The return statement. The return statement lets you get a value out of a method. We had get miles, which returned the number of miles, the state of that object. We also had Twostring, which returned a string that contains some state information about the object. If something does not need to return any values, you instead declare it as void. Void just means that there's not going to be a return statement in this function, or if there is, it's not going to return any values. An empty return statement. For methods with an empty void type, it's legal to have an empty return statement. It's not mandatory, but if you like seeing return statements in your code, you can do that. Drive here is a void method. If I wanted to, I could tack on a return statement down here. Of course, then NetBeans thinks that it's smarter than us and goes and warns us, that's an unnecessary return statement. And it is. You don't have to have it, because it returns anyways when it hits that closing brace there. But a function like this that is declared to have a data type that's not void, you have to have a return statement, and it has to match the data type here. Since this is declared as returning a string, the return statement here had better be something that can be a string. Get miles is declared as being an int, so it had better return an int, or something that can be easily converted into an int. What do I mean by that? Well, if miles for some reason was a double, but we declared this as an int, we'd better convert it to an int before we return it. Argument passing. Argument passing is when you pass something in. We only passed in one argument in each one of these classes, in the drive method and in the spin method inside the wheel. We are declaring a parameter called miles, which is used to determine how many miles we've driven. Here, when we're looking at the code for the class, that's called the parameter. But when we're looking over here, these are called arguments. That's the argument, that's the argument, that's the argument. It's a subtle distinction, but when you're at the client code and you're looking at the value or the variable that's being passed in, that's the argument. When you're inside the class itself, you refer to it as the parameter. A parameter is a variable name that is declared within the parentheses, and the argument is a value that is fed to it by the function call, by the method call. So here we are invoking the drive method. We are calling the drive method. We are passing this data in. That is our argument. When we're inside the car, this parameter, this variable declared within the parentheses, is now set to 100 or whatever the argument was so that we can use it. That's how you get data into methods. If you want to stick something inside a method, you put it in a parameter. If you want to get a value back out of the method, you use a return statement. Mutator methods are the setters. Here they have a mouse simulator where each time the mouse grows older a day, it grows by a certain amount. They decided that age was not going to have a setter. The age was going to be tracked entirely within the mouse class, and so was the weight. However, you did want to be able to set the percentage growth rate, so they added a setter for their mouse class that allows you to set the growth rate. The format, the names that you should give these guys is just generally the word set followed by the variable name, but with an uppercase letter. So if we have, a class, always name your classes uppercase. There we go. If we had that, and then we wanted to get a setter for those, it would be set X. Then if we wanted to get a getter,
Let's start with Floyd.
let's see, private, public. So we want the getter to be called by the client code, so we would not define it as private, we would define it as public. And what data type is the X? It's an int, so that's what I'm going to use as its return type. Do I want to pass in a value? No, because I'm asking you for your value. I'm not going to give you your opinion as I'm asking for it. So here we go. Return this.x. Like that. So this was the setter, which makes it the mutator. Got to have fancy Latin words whenever possible. Then this is the getter, so it's the accessor. And I am going to show you how to make NetBeans fill that stuff in automatically for you. So go over to projects, create one more class inside your package, new Java class. Just keep it the name new class. It doesn't have to have any special name. Now create something with several variables. Int x, double y, string z, something like that. Then highlight those three guys and go to the refactor menu and choose encapsulate. You can also right click and choose refactor. So refactor encapsulate fields, and we see it's offering to create all these getters and setters. Now maybe we decide that X wasn't supposed to have a setter and we might deselect it or something. I'm going to go ahead and leave them all. You click refactor, click the refactor button, and what it does is it adds all those getters and setters for you, which is kind of cool. So there's absolutely no reason not to add getters and setters. So there's absolutely no reason not to make your data private. because it makes it this easy to add the getters and the setters for it. And then you get annoyed because it's got all these extra comments in your code, but oh well.
Did that clock stop tonight?
It might have.
It must have. It's been an hour off all week, and so it probably shut off right as class began an hour ago. But, speaking of that, it's time to shut ourselves down. Let's create a Dropbox for what we've done so far. Okay, and the homework assignment, I hope it's not too close to something we've already done in class, but if it is, then you could just reuse what we did in class, is to make a sphere class. But I'll talk about that after we get the Dropbox made so that y'all can be doing that. In class, this is going to be in class A, B, C, D, H, G, K, L. Alrighty, it's there now. Refresh and add to it. Okay, so here, have I assigned this one? Have I given y'all a class named Sphere and asked you to implement it?
Yeah.
Well, cool. Alright. No homework from today then. I could come up with another one. But I don't want to, it's already 8:20. Nah. We'll wait till Monday, Tuesday. Alright guys. I'll see y'all Tuesday.
All right. Have a good night.
Oh, you too.